And welcome back. So that was a great tour around cloud services. And if you remember from the first session, we were kind of saying that's ultimately what you want to get your application to, which is why what we started first. But as Tyler kind of went through it, he kind of said, well, you need to start getting into service packages. And it's not really something where you could just pick up and kind of move over. So what we thought we'd do this time, and Bruce is here. Welcome, Bruce. Thank you.
Hi, John.
Thanks for
Good
joining.
to see you as always.
Well,
Always, sir. It's always good to see you.
Likewise. But this guy here is the master of virtual machines. Now, I say master only because not only can he obviously talk about it,
Yes.
but he's actually implemented several of these within the Object Sharp, which is the company you work for, in their infrastructure, and knows this stuff like the back of his hand.
Yes. Wow.
Okay. Anyway, point is, what Bruce is going to show you is actually now kind of on the virtual machine side, which is, if you remember from the first session, basically the idea of actually having a server and full control over it. So
yeah, exactly.
Full
It's yours. It's your machine.
Means it's all yours.
It's not just like a machine. It is a machine.
So with that, I'll hand it over to Bruce. Think about this now in terms of how easy it would be from taking your existing infrastructure, and especially if you're already running Hyper-V.
Yes. Yeah, absolutely.
Right? And then bringing it into this world. So with that, Bruce, it's all yours.
Thank you very much, sir. Pleasure. So basically what we're looking at is, if you take a look at the slides, we're where we are in the middle of things. We're right smack dab in the middle. So we've been working with, we've been talking about software as a service. We're going to be talking about platform as a service coming up. But infrastructure as a service is really what we're talking about when we're dealing with virtual machines. Right smack in the way between the physical, where you're running it on your end, versus the complete software in a cloud where you're not worried about it at all. And this ends up being quite a compelling offering when you get right down to it, in terms of what it provides for you. So what we're really looking at more than anything else is these are machines that you control. These are VMs, and as you'll see, they're VMs you can configure from a gallery so that you can actually go and pick from pre-configured machines, but you've also got the ability to bring your own VHDs and push them up into the cloud and be able to work from it. So these are machines from just about every definition you might want to look at. The idea here is they're going to support your key server applications. They're your machines. You can run them, do what you want with them. Manageability of storage is an interesting, potentially an interesting problem, and there's a solution that the servers have that actually allow you to very easily ramp up and ramp down different servers. We'll talk a little bit about that. They've got support for high availability. They've got some supports for some really cool networking capabilities. The ability to have those virtual machines play with the machines that you have inside of your network or become one of the machines inside of your network. And then, of course, we have the ability to integrate with some of the platform as a service functionality as well. And really and truly what we're dealing with here are the different kinds of workloads that you might possibly have. And so we're looking at really three different areas. We're looking at line of business applications, where you've got custom applications or CRM machines, CMS, any ERP, business intelligence that you might possibly have, the things that you normally have inside of your environment. There's application infrastructure, so file services, databases. You can put Active Directory onto these machines so that you can actually have, you're controlling your identity from your organization through these. You've also got the ability to put source control, so I can install something like TFS up there. My ability also to very quickly provision and unprovision entire environments is actually very cool from a development perspective. One of the things you run into if you're trying to develop any kind of significant scaled software application, you've got the problem of if you want to test something, hey, look, I need to spin up a web server, I need a database server, and I need to deploy my application. And you have to go and requisition hardware from the people who actually put the hardware together and put it into your system. With the VMs that you see, that's no longer an issue. You actually can take your VHDs, spin them up, or just simply spin them up out of a gallery. You can do that through PowerShell, so you can do it as a scripting level, which means you can do it as a task coming out of TFS, out of one of your builds. You can deploy your software to it, run your tests, and then shut them down. And the nice thing about that is, even though, if you look at the monthly cost of the virtual machines, they can go run from, $50 a month on up. That's $50 a month, presuming that you're using it all the time. The low-end cost is pennies an hour, and so if you're only going to use it for a couple of hours, you're not spending a lot of money. You can spin them up, test, run, spin them back down, and you're not adding a lot of cost to your infrastructure. So very, very cool workloads that you happen to have available to you. As well, there's the hybrid applications, the idea that you can have your data center and the cloud be as one. So that you can be one with your entire network. But no, the idea here is that you can actually have apps running out on these virtual machines. You can have portions of your application, like your database, running internal, and you can have the two of them connecting together. Again, very powerful combinations of things that we're going to be that are available to you. And we're going to be talking about those a little bit later on in the afternoon as well. Now, as of right now, you've got a number of images that are available to you. I said you can actually pick from a gallery of images. There are 8 or 9 that are built in that are just simply available to you, and they generally come from 2 sources. You'll notice that we have access to a couple of Server 2008s, a Server 2012, the release candidate for that. There is access to a machine that's got SQL 2012 evaluation, enterprise evaluation running on it. So you've got a number of built-in pre-configured servers that are available. As well, there are 4 or 5 Linux distributions that are available. Now, these Linux distributions are actually coming from partners that Microsoft is collaborating with to actually provide these particular images to be able to go out and support them. But you can go in and spin up a virtual machine and you can load OpenSUSE on it, or Ubuntu, or CentOS. And so you can very easily just simply pick up a Linux distro, push that out to your virtual machines, install whatever apps, whatever functionality you have, with database you might have running on that, and there you go. It's not, the virtual machines themselves are not Microsoft-centric. They're just virtual machines that you get to do what you will with. So in terms of getting started with them, there's a number of different ways you have to actually build out your virtual machines. So we've already mentioned the idea that you can actually do scripting. So there is PowerShell scripting that's available. You can script it from Linux or from a Mac if you need to be able to. There's a REST-based API, and there's also a management portal. They've redone the Windows Azure portal so that you can go and manage your virtual machines through that particular environment. So you've got all those choices. When you pick a particular server, you've got about 3 choices that you really have. You can pick one of the things from the gallery, so you can pick Windows Server, you can pick a Linux machine, or you can upload your own images that you've created in-house. You can upload them into Azure, and then you can use those as the source for whatever virtual machines you might want to create. You also get to pick the size, and we'll talk about, you're going from extra small to extra large, and we'll talk about exactly what those mean in a couple of slides. And then you can also boot your VM from a new disk. So you basically can create yourself a brand new machine from scratch. And so now you've got the ability to install whatever versions of the operating system and basically configure it as if it was a piece of bare metal. So you can go anywhere from going from a gallery to uploading your own to it's a brand new machine, and you just simply get to go out and work with it however you want to work with it. So incredibly flexible options happen to be available to you. As I mentioned, you can bring your own VHD. And so when you're bringing your own VHD, what we're talking about is you have your own virtual server on premise. You're using Hyper-V. You're building a VHD up from scratch. You can then, what you end up having to do is you have to generalize, you have to sysprep your image, and then you can migrate that VHD up into Azure. It becomes a part of the storage. It goes into Azure storage. And once it's in Azure storage, right, it becomes the source, or potentially it can be used as a source to create your virtual machine images from. So you can put as many as you want up there, and that way you can spin up or spin down the virtual machines as you need to. From a costing perspective, this is actually fairly slick because basically what you end up paying for is the cost of storage. On an ongoing basis, you pay for the cost of storage. So if you put 20 gig VHD up into blob storage, you're going to end up having to pay for that particular storage. It's not a lot of money. It's not dollars per month kind of thing for that size, but it's there. But then what you can do, and I'm now going back to my, my testing, bring it up, bring it down scenario, you can basically keep it up there for a couple of dollars a month. You can say, hey, I need to run a nightly test. I'm going to take that, use that as a source for my virtual machine. It spins up the virtual machine. The tests run for an hour, spins it back down again. And now all of a sudden, you've spent an hour's worth or 2 hours worth of compute time on the virtual machines, and you have the ongoing storage. For not a lot of money, you can have an incredibly flexible environment that you're working from. Right? You've also got the ability to image your VMs inside the cloud. So you can take your base VHD, so you can go into the gallery, or you can even take one of your images. You can create yourself a VM, boot up the VM, customize it, add whatever software you want, install whatever things you might possibly need, and then you need to generalize it. And that basically you're now removing any of the specific machine-specific information from it, and then capture that VM, and it will now store that VM into blob storage as if you had pushed it up there yourself. So from that perspective, you've now taken some base image, added additional things, maybe you've installed a database, your own database, you've got your own custom applications you're installing, you push all of that stuff out there, snapshot it, more or less snapshot it, generalize it, store it in blob storage, and now what happens is at any point in the future you can create virtual machines using that particular image. And so it ends up being, again, a very flexible way of automatically moving things up and down, creating things as you need them. From a mobility perspective, these images, we've already talked about taking them and taking images, taking VHDs that you create on-prem, being able to move them up to the cloud, but it turns out you can also go the other direction. You can take the VHDs that you've created up in the cloud, and you can bring them back down to your premise so that you can move them back and forth. I mean, I say that like moving 20 gig or more back and forth is something you want to do every day. I'm guessing it's probably not. But when you need to be able to do it, if you want to be able to take a snapshot backup of a server, be able to bring it down onto your machine, onto your premises, so you can store it however you'd rather store it, you've got the capability of doing that. And that virtual machine that you just brought down is completely capable of being loaded up into Hyper-V on one of your physical machines and uses exactly the same machine there. So you can move these images back and forth quite conveniently so that you can flex where you want to be, where you want to happen to put things. One of the things I mentioned earlier on is that there's persistent storage is kind of an interesting problem when you're dealing with virtual machines. One of the things about the way the VM's working in Windows Azure is, like any virtual machine, you kind of have this disconnect between the physical hardware in which the stuff is running and the actual virtual machine image itself. And to try and arrange for a level of redundancy that happens to be out there, you don't want to have everything inside of your virtual machine. You don't want to put it in that VHD. Ideally, if you store data as a result of your virtual machine doing whatever it does, you want to be able to have that data stored someplace else so that if you need to shut down that virtual machine or it crashes for whatever reason, you want to be able to take the image, push it up to another physical machine, and pick up the data where it happened to be. And so to do this, when you actually create the virtual machines inside of Azure, you end up with two disks that happen to be available. There's an operating system disk, the C drive, and it is 127 gigs with a max capacity. It's capable of being imaged, so you can snapshot it if you need to, but this is basically the idea where your operating system happens to live. It is not recommended that if you're writing stuff out there, you write to anything, you write to the C drive, okay? Because the idea is the C drive is where your OS lives. They can just simply, refresh it, clean it, and off it goes. There is a D drive, and the idea behind the D drive is to be a non-persistent cache. So that if you have temporary files you want to store stuff, you don't want to write them to the C drive, you write them into the D drive. But if something were to happen to your VM, it was to hard crash, they spin it up on another physical machine quickly, anything that's on that D drive ends up being lost. So if you've got temporary files you want to work with, you can store it to the D, but it's not guaranteed to be persistent over a period of time. If you shut the machine down, you start it up, the D drive could go away. That's generally not being able to have persistent data. It's not a great idea. So there are the ability to have what are called data disks. And so depending upon the size of the machine, you can have 1 to 16, I believe, different data disks available, each one of which can be up to a terabyte in size. And so those data disks end up being your E, F, and so on drive letters. Now the information is actually persisted there, and it will stick around. And the idea is that if you do have the virtual machine, something happens to it, it needs to get another instance of it needs to get spun up. It's still pointing at that original that persistent drive, so none of your data ends up being lost. You can spin up multiple machines sharing that particular data as the data drive as well, so that you've got that ability to share between even different virtual machines that happen to be running out there. Now, I've mentioned the different virtual machine sizes that happen to be available, extra small to extra large, because that's just simply how you do T-shirt sizes. So if you take a look at the extra small, you'll notice you've got a shared core. So what you have is multiple virtual machines running on the same physical machine, 768 meg of RAM, one data disk, so one terabyte of data disk can be available, and a bandwidth at 5 megabytes. And I believe there's also the amount of download that you can get ends up being limited as well. You can take that all the way up to an extra large, where you're working with an 8-core processor, 16 gig of RAM, up to 16 terabytes of data, and bandwidth at 800 megabytes per second, which is, I think, the technical term, that would be a big honkin' machine, right? So you can go any place from low to high, and you're only ever paying for what you use, which goes back to what I was saying. You spin something up for a short period of time, you're paying per hour, and you get rid of it. And it's, the idea, I want to say, even when I'm getting an 8-core machine, the cost runs someplace less than $1 per service hour. So I can get an 8-core machine at $1 an hour. That's a good deal, especially if I'm going to use it for a few hours at a shot. Already mentioned the scripting capabilities. If we're going to be able to do things like automatically deploy stuff out of builds, or if I want to be able to have administrators be able to manage this, I need to have scripting capabilities, and that's exactly what happens to be available here. So it's got PowerShell scripting. I've mentioned you can script off of Linux, you can script off of JavaScript, you can script off of Mac boxes. So the platforms, you can script pretty much from everywhere you go. And the kinds of things you can do are pretty much soup to nuts. You can provision, remove, reboot, start, delete. You can import and export VM settings so you can push them around between different machines. You can do domain joins. So pretty much anything you need to do with those virtual machines, you can actually do while you're scripting, which works out to be quite a nice little environment. Now, excuse me, let's actually take a look at what's involved in this. And so if I look at my demo screen, you'll notice that this is what the new the Windows Azure management portal looks like. And so what we're going to do is, just so you can see what it looks like to create a new virtual machine, you'll notice at the bottom left there was a new button. When I click, I can basically add a whole bunch of new stuff. I'm going to end up adding my virtual machine from a gallery. And now you should see I've got a list. So I've got BizTalk, SQL Server 2012 eval. That, by the way, is an eval of the enterprise license. A couple of different Server 2008 R2s, a Server 2012, CentOS, a couple of Sissies, and an Ubuntu. So I've got a number of choices that I happen to have available to me. I'm going to select that one for no particular reason. And so now I get to give it a virtual machine name. And you just simply provide a name that seems reasonable. Give it a password. Confirm it. Right? And you'll notice that I've got the choice of machine that I want to use. So again, anywhere from small to extra large. And you can change that after the fact, so it's not like this is a decision that happens to be set in stone. So at this point, I now have a couple of different choices available to me. Now, which one I pick is going to depend upon some load balancing functionality we'll talk about in a couple of minutes. But the idea here is I can create a standalone, or I can connect to an existing machine. If I'm going to connect to an existing machine, I'm basically setting up a load balancing scenario between those two machines. All right, I can use a storage account or an existing storage account. I specify my region, so I can have this be in different regions depending upon where I expect the server to be used. All right. And then I've got an availability set, which again we'll talk about in just a couple of seconds with respect to availability. So I can either create my own or I can actually work with an existing one. And I'll kind of finish that up. I'll talk to those in just a couple of seconds. Okay? That's basically it. And once you do that, you end up with a machine that goes through the process of being configured. And it takes about 7 or 8 minutes to actually start up a virtual machine from scratch, which if you think about it, isn't that bad at all. And we'll kind of get back to that in just a couple of seconds. So when talking about virtual machine networking, we have a number of choices available to us. First of all, full control over machine names, right? So you can either go through Windows Azure to get your domain for your DNS services. You can have your own DNS server that happens to be available to you. Each one of the machines has their own an internal and external IP. Very easy to map whatever domain you want onto those particular IPs. So you've got a lot of choices there. In terms of the endpoints that are supported, UDP, all of your IP-based protocols, pings, dynamic ports. This is a machine it supports. It's a server. It supports all of the stuff you would expect it to support. There is a custom load balancing that is in there, and I was showing you how to set it up a little bit when we were configuring that first virtual machine, that you can automatically arrange for two virtual machines to have a load balancing relationship set up between them. In terms of availability, right? There are basically two service level agreements that are provided. There is, if you've got multiple role instances, which is more or less, I have two virtual machines identically configured, and I've got them load balanced. They will give you 99.95% uptime. So you're talking about a little over 4.25 hours of downtime per year. If you only have a single VM, right? So in other words, one instance, no load balancing, no redundancy, you're looking at a 99.9% availability. Now, the availability is for computer hardware, for network failures, for data center failures. It does not cover you installing something that breaks. You install something that breaks, that's pretty much on you, okay? So, but from a reliability perspective, that's fairly decent. And one of the ways they do to configure this is to use these things called fault and update domains. And so the idea behind these concepts are to find ways to isolate the machines so that if one machine goes down, there's another machine ready to pick it up. And if an update takes place, you can update the machines in a reasonable time frame, because one of the things about having the VMs in Azure, they're responsible for managing things like the operating system, right? Managing things like the underlying hardware. So when upgrades need to take place, they're kind of responsible for it. So the way this works is along the following. One of the choices we had was an availability set. And so if I actually take a look, you'll notice that I've got what appears to be here I've got two different IaaS boxes and two different SQL boxes, the kind of typical thing you might see if you're trying to have some redundancy. And so an availability set is, again, two machines that have that need to be available, or at least one of which needs to be available. And so my two IaaS machines need to be available because they're running my web application. My two databases need to be available because they're running my database side. And then conceptually, I need to put them into, like I would put these in a rack. If I was configuring a room, that's what I would do. I'd arrange for these two types of machines not to be on the same physical rack, because that way if the power goes out to the rack, everything doesn't just simply crash out of me. I'm trying to reduce the number of points of failure. So at a conceptual level, Azure puts what's called a fault domain along the kind of division you would normally expect to see along a rack. Okay, and so basically the idea is my fault domain consists of an IaaS and a SQL, so that if any one of those goes down, I have another one that happens to be out there. And then what they do is they create an update domain. And the update domain basically says my update domain is such that I can update one IaaS machine, but not the second IaaS machine simultaneously. And the same thing applies to my SQL machines. I can update one of them, but not them both simultaneously. And so by doing that, Azure is better able to actually control the uptime that happens to be out there for these particular machines. And the way this relates to the SLA is pretty much as I said before. Single machine, single virtual machine, 99.9. But if you actually set up an availability set, now you're 99.95% uptime. And the way to configure this is to, if we go back into the process, I'm just going to go back into the process here of actually creating a particular image. Just type the stuff back in again. Okay, so the first thing I need to do is I need to connect to an existing machine. By connecting to an existing machine, I'm basically saying, here's my load balancing environment that I happen to be working from. And then once I've done that, I have the ability to specify an availability set. And so my availability set allows me to, within a single machine, I've got here's all the machines I happen to want to configure. And yet, here's my cross-cutting fault domain that I want for. I want to make sure that these two things are all part of these machines, which are all part of fault domain, update domain, are actually configured inside of both the update domain or the availability set that actually allows Azure to control how updates are performed and how fault tolerance is actually managed. Okay, so by now you need to plan this out beforehand, but by doing this, you actually get that capability of configuring a fairly reliable system all the way up and down. Okay, so now talk for a couple of seconds about virtual networks and how that happens to work out. Because one of the things you run into when you start to work with virtual machines is how do I make sure that those machines can talk back into my enterprise. And there's a number of different tools that happen to be available inside of the Azure world to be able to allow for this. So I've got the ability, for example, if I'm trying to synchronize databases, I have something called SQL Azure Data Sync, which will allow me to synchronize my database from SQL Azure back on premise so that I can then do backups or something like that I might want to. I've got a service bus availability that allows me to do messaging both to and from the cloud. Once I get down to the machine level, I've got something called Azure Connect, which allows for machine-to-machine network connectivity. And then I've also got Windows Azure Virtual Network, which allows a site-to-site virtual connectivity. And when I use those tools, now all of a sudden, I start to have my machines become my Azure machines become part of my corporate network. And that's really what I'm trying to get to, so that I shouldn't care as a developer. I shouldn't care whether this machine is running, in Azure or not. And these tools actually allow you to get to that particular point. So the kind of scenarios we're dealing with are the hybrid cloud, public and private. So I have some machines sitting out there on the cloud. I have some machines sitting on-prem. They're networked together, right? And you can actually extend your domain out to the machines running in Azure so that from those machines' perspective, they're part of your domain. And now they can access, you can have your web server accessing your database by name, not needing the IP address, not having to go through that kind of a check. They just simply become part of your enterprise infrastructure. By doing that, I've also got the ability to have integration with on-prem Active Directory. So I can have my VMs, again, be part of that domain and now participate in all of the domainness that happens to go on with having Active Directory around your organization. The fact that it's part of my domain now means it's managed in the same manner. So System Center actually will communicate and will actually interact with the Azure VMs. And then I've got, from a persistency basis, I've got the ability to have persistent IP addresses, right? When you start to look at what you need to do, these are the kinds of questions that you end up asking yourself. If your app needs a virtual network, generally speaking, it's because you need to share your resources both on cloud and on-prem. And Azure actually allows for all of that functionality to take place. Right? And this allows you to do the side-by-side thing. You can also go so far as to actually have your IaaS, your infrastructure, and your platform as a service interact together. And one of the reasons this happens to come up is because, back that up a second. One of the reasons this comes up, and we're going to talk about it again in about 45 minutes. One of the reasons this comes up is the idea is that you can have some of your stuff running in web roles, worker roles sitting in the cloud. You can have some of your stuff running inside of a VM, and it happens to be right there and ready to go. You can have them communicate with one another. And the reason for that happening has got to do with exactly how Azure partitions these services inside of its environment and therefore inside of your infrastructure. And again, we're going to be going into that detail a little bit later on this afternoon. But ultimately what it means is that your applications don't care. And really that's what you care about more than anything else, is your applications will just simply work and function, and they'll do all the stuff that you happen to be able to do. So ultimately that's what we've been talking about. The idea here is we've got server applications that you can do whatever you want to. These are VMs. You can do anything that you happen to want to do with them. You've got storage manageability in that you can have the data disks that are available. Those data disks will persist from reboots of the virtual machine. And from crashes of hardware and everything related to that. You've got a lot of high availability features, so you can create yourself connected machines. You can create yourself availability sets, fault domains, and update domains so that you can ensure very high level availability for your site. You've got a lot of advanced networking that will, let you create those hybrid environments. So you have that capability of, I've got something running in the cloud, I've got something running on-prem. They can talk to one another through databases or through service bus or through TCP or through your domain network. It's invisible to you. These are just simply machines running. And if you happen to have an organization that is already in virtualization mode, we're already running Hyper-Vs, you already have that environment anyway. So actually being able to take that environment, push it out to Azure, what it really does is it means you no longer have people crawling under the desk plugging in wires anymore. the machines are handled by other people. Not to say that admins aren't needed anymore, because they certainly are, but the kind of administration they do ends up being much more about configuring and managing the system and less about, do I have to worry about what my mean time before failure happens to be. And then finally, we've got integration with the rest of Azure, the idea that I can integrate with websites and mobile services and platform as a service and all of that functionality. Okay, so we're going to be going and taking a break now. We should be back in, I want to say, about 15 minutes for the next session. Until then, feel free to give us any questions that you have online. We're happy to answer them, and we will be back shortly. Thanks.